Right, Workplace 30, welcome to class here. We're going to take a look at 1.3 today. And 1.3 talks about scatter plots, and linear trends. Okay, so a scatter plot, if you were to plot points on the graph, okay, that's really a scatter plot, okay? So we've been plotting points all chapters so far. So to put a bunch of points on the graph where your independent variable and your dependent variable, where they kind of meet up, that's the point that you place on the graph, and that creates a scatter plot. So it's a particular type of graph used to discover what relationship, if any, exists between two variables. Okay? So we've been doing that. So just a couple examples, right? If you have a scatter plot like this, as the independent variable gets larger, so does the dependent variable, right? Usually something like age and height, right? As you get older, you grow, okay, until you get to be an adult, and then you really don't, you don't grow much anymore. And as a matter of fact, when you get old, you start to shrink maybe because your bones compress and you whatever. But yeah, it could be age and height. What else? What other kind of relationship of two different things both increase together usually? Can you think of anything? They both increase. So if one increases, another related variable increases as well. The weather. What about the weather? What does that mean?
One day, one
Okay. You want to rethink that?
Filling a bucket with water.
Filling a bucket with water. Okay, so what are the two variables involved? Or what are the two quantities?
So one of them is the amount of time, and one of them is the level of water.
Oh, very good, very good. Okay, so the amount of time that you're pouring water into a bucket, and then the level of the bucket. The level, perfect. As time gets larger, more time, higher level. Good. I would suggest that the more time you spend studying and doing your work, the higher your grades will be. Especially if you actually submit things. Yeah, that'd be awesome. So that's, again, amount of time studying, your marks go up. Boy, wouldn't that be a great graph to see? Okay, love it. Okay, those are good thoughts. The teacher has to put in the teacher one, right? I'm sorry. Okay, so points that represent data are drawn on a coordinate plane. Then the graph is examined to see if a trend or correlation exists. Okay, so here's a big word, correlation. The correlation is the degree of relatedness, I'm not sure if I like that word, but between variables. So it's like how closely they're related. Okay? So the amount of studying time and your grades going up, you know what I mean? Would that be for every hour that you spend studying, does that mean 1% roughly? Or you know what I mean? What if you spent 100 hours 1 week studying? Does that mean you get 1,000%? Or you know what I mean? I don't know. So the correlation is sort of how closely, if one moves, if the other one moves at this kind of at the same rate, that's pretty correlated. That means they're really connected. Okay. Age and height. Okay. As you grow in age, your height may vary quite a bit. Especially you boys have a growth spurt in your teens, right? So your age kind of goes like this, or your age goes like this every year, and then your height kind of goes like this, and then all of a sudden there might be a big growth spurt. So is that correlated? Not. The correlation is, What about something like this? Well, if you have points like this, right, and it looks something like this, it's like, oh, that's all over the place. Is this happening? Is this happening? Is this happening? Is this happening? So those are not correlated. That means there's really not much of a connectedness between the variables. Okay? The line of best fit, I think we've talked a little bit about that as well. But if there appears to be a correlation between the points, you can draw a line of best fit. And a line of best fit is a line that shows the general trend of the data, or it's a line that goes kind of through or close to going through most of the points. So for example, up here on the left here, if we have points that go like this, that looks pretty linear, doesn't it? A line of best fit would travel through as many points as possible, a straight line. If we had something like this, a line of best fit would be sort of the line that passes through Let's try a little bit better. A line that passes through the majority of the data. And you see how these points are kind of like they're far away, but they're equally spaced. So there's an equal kind of spacing of the points away from the line. You know what I mean? So it's a line that kind of says, hey, generally this is what's happening, either going up or down. So age and height, generally the line kind of goes up, like it's kind of like this, right? Your age goes up, your height goes up, that kind of thing. All right, so notice here, it doesn't have to pass through all of the data points. Like it doesn't have to go through all the points. Like these ones, are not on the line, of course. And it's not like a broken line where you're connecting all the points. It's not a broken line. It's a straight line. But approximately the same number of points should be above and below the line. So that's another good way to look at it. If the points cluster close to the line of best fit, there's a strong correlation. Okay, so here we go. If the points, let's say these didn't exist, and all the points were like very close to the line of best fit, that means there's a pretty strong correlation. As one variable moves, the other one moves predictably, If the points are all over the place like this, there's a few more, and that's like, not a strong correlation. Yeah. Okay. So, time of year and amount of rainfall, maybe. Generally you get more rain in the spring, but it varies quite a bit. So those points would be all over the place, right? And we've gotten a lot of rain this month, right? We've gotten more rain in the first week and a half, I think, or 2 weeks than we normally have all month. So the data points could be all over the place. So time of year, you can't pinpoint exactly how much rain you're going to have because it varies a lot. So that's a weaker correlation, okay? Is it making sense? You guys are listening very attentively. I appreciate that. Is this sinking in? Is it kind of like, yeah, pretty good? Okay, so those three things here are really important. The final thing on this page that I'll tell you about is called an outlier. Has anybody heard that word before? An outlier? Maybe? Okay. So an outlier is a point that lies significantly outside the general trend of the data. So it's kind of like an aberration, or another word for it would be sort of like a point that is like a one-off, It's like, oh, that doesn't really belong with the rest. So let's say we had, let's say rainfall. So rainfall for a given month, let's say, is about 40 milliliters, or 40, milliliters. We'll go 40 milliliters, okay. Or inches of rain, even centimeters. 40 centimeters of rain for a month. And over the course of 10 years, we have 38, 42, 40, 39, 37, 45, and then we have one that's like 60, right? If that's like the only one that's vastly different than the rest of the data, that could be considered an outlier. So it would be like this. Let's say that we have a test or something, and not naming any names, of course, but let's say that everybody gets 100% except for one person that's like maybe down here. Well, the general trend of the class is it's 100%, right? Like that's kind of where everybody is, but maybe this one person got a little bit lower than that. So that would be an outlier. Or think about it, another way. There's the rain, okay, there's marks. Maybe somebody's height, right? Maybe the average height for, high school students is maybe 5'3" or whatever, 5'4", 5'5". And then you have someone that comes in and 7 foot tall, right? So that height would be not really indicative or not really representing the average or the correlation between age and height. Does that make sense? Okay, so an outlier. All right. Okay, so let's go back to the line of best fit. Using the line of best fit, you can find the following information out. So the shape, okay? Now, a line of best fit is usually straight unless you have points that kind of look like this. And they're an obvious kind of, if there's like a curve that shows up, sometimes it's like this. And sometimes you can draw a curved line of best fit. Maybe that's not that great at the end, but so it could be linear or nonlinear. The strength of the correlation, right? Are the points close to the line or far from the line? The direction, is it going down or is it going up? A positive correlation means that it goes up. As one variable goes up or quantity goes up, the other one goes up. A negative correlation would be as one goes up, the other goes down. That's a negative correlation. All right. And then you could see if any outliers exist too. Obviously, we just talked about that. But if you have points that look like this, and then you have this guy up here, it's like, okay, now is this the line of best fit? Because you got to consider this guy as well? No, that's not the line of best fit. The line of best fit would definitely be like this, right? And then this one you'd kind of say, outlier, I'm almost going to forget about that one. It's like a fluke, right? It's a one-off. So, okay. So outliers would be points that would be way, way far away. The few points or 1 or 2 points that are way far away from the line of best fit. Okay, so let's take a look at these graphs. So what are the questions? Whoops, we're going to have to go back here. So let me just clip these out so I can put these questions with the graphs. So page 56 is where we're at. Come on now. Oh yeah, come on, out. There you go. Oh, this is not behaving here for me. Okay, so here are the graphs, and I'll try and put the questions out here, okay? Where we can see them, preferably. All right. So is this graph linear or nonlinear? So let's take a look at A. Does the relationship, does it seem to be linear? Would it be reasonable to draw a straight line through those points? Yeah, for sure. So again, you use your ruler, not freehand like me, but that'd be kind of the line of best fit would look something like that. So yeah, pretty linear. This one, linear? Well, we have some points for sure that are kind of outliers, I would say. This one and probably this one. But that's fairly linear. This one, oh boy. There's hardly any correlation at all, right? I mean, do you draw a line there? Do you draw a line there? Do you know what I mean? So this doesn't look linear. This definitely is non-linear. You see how this kind of makes, a nice smooth sort of curve like this? It's like an exponential function or exponential curve or something. All right? Direct or partial, well, this one looks like it could be direct. That looks like it could go through 0, 0. This one would be partial. Okay. What is the direction of the correlation? Well, if it's a positive slope, it's a positive correlation. That make sense? A negative slope, a negative correlation. What's the strength of the correlation? This one is pretty strong. This one is not strong. Okay, that's a weak correlation. And that, for a nonlinear, would be pretty strong, I guess, because the points are pretty close to that line. And are there any outliers? Yeah, these two for sure. And then I don't know what you say about these. Like, I don't know if you can call all those outliers. I don't think so. But these ones are obvious. That to me anyway. So let's take a look at the answers. What does it seem to say? Is there anything different here that they say that we said? Okay, no, A looks pretty good. Negative correlation appears to be two outliers. Yeah. No relationship for C. Nonlinear. Oh, we didn't say there's a positive correlation here with this one. But even in nonlinear, you see how one is increasing, so is the other one. It's just increasing in a nonlinear fashion. Okay, so let's do one together. Okay, so it's a good idea to have a straight edge here. Okay, even if you have a straight, like a piece of paper or something, or another pen or something, or a ruler obviously would be best. But if you're going to draw a line of best fit, a clear ruler would be the best, so you can see the points that you're covering and the points that you're not covering. That would be best. So identify two similarities and two differences between the graphs. Oh, that's a good question. Okay, I'm not going to write this down. We're just going to talk about it, but you need to write this down. So what is one similarity between graph A and B here in number 1? Name me one similarity.
Positive correlation.
Very good. Both of them have a positive correlation, I would say. Yeah, because generally this line goes up and generally this goes up. So yeah, so similarities, positive correlation. That's awesome. Anything else you think would be a positive, would be a similarity? And it would be a good idea to maybe look at the types of questions that were asked in this, like over here, right? So what about linear? Do they both look linear? Is that a similarity or is that a difference? Anybody else? Anybody else want to answer? Do they both look linear or not? Would that be a similarity? If you were to draw, could you draw a line of best fit here? Yeah, this one, I don't know. I think this one might be an outlier, but a line of best fit might look something like that, and so would a line of best fit here. So they're both positive, yeah. I would say they're both fairly linear, like as far as their relationship. So I would say they're probably both linear. Okay, what about two differences? What's difference? I'm thinking of two right away here. What's one difference that you see?
The outlier.
A has an outlier. Very good. Yeah, I would say that B probably doesn't have an outlier. This one has a clear outlier. This guy is totally out to lunch over here. Yeah, totally doesn't know what he's doing. And what's another difference? Look at all the points here, and look at the points here. And what about those questions? What else were we asked to comment on? Look at this one. The strength of the correlation. So what would you say? How would they be the same strength of correlation, or would they be different?
It's probably stronger.
Yes, I would say so too. A probably has a stronger correlation because the points seem to gather closer to the line than in B. So another difference would be B is weak, has a weak correlation, and A would have a strong correlation. Okay, so it should be two differences and two similarities that we've talked about. Okay, so we won't go over two together, but you're asked to draw this scatter plot, so you'll get to do that later. Now notice that the numbers are all jumbled up. You see that? So you're going to have to either arrange them in increasing value for x or something, or you just make sure that you have the right scale that you can fit all of the, all of these values on here. Looks like it goes from 0 to 6 or so. And so you got to have 0 to 6 on there, and then y goes from about what? 0 to 5.5. So you got to have 0 to 6 up here too, and then just put the points on the graph somewhere and see what happens. Is there there'll be some questions on that one, number 2, right? Describe the relationship and so on. Okay. Okay, so let's take a look at example 2. I'll leave that number 2 for you to do later. What about example 2? Draw a line of best fit on the scatter plot below and write an equation for the line. Ooh, we get to use 1.1 now. So you're going to have to remember 1.1, writing an equation. If it's a direct relationship, remember it's y equals what? What's the equation for a direct relationship? Who remembers? Y equals mx. Direct is just y equals mx. Indirect is y equals mx, when what you said, plus b. And b would be the intercept. Technically, you could say plus b for both of them, really, but b would be 0 in the direct. Okay, so your lines of best fit will maybe look just a little bit differently from mine or from each other, so that's okay. So what you have to do is you have to try and with your ruler, draw a line of best fit that would go through these points. So I'm going to do this. I'm going to try this. So now, where's the line of best fit there? So equal number of points above and below, and the spaces should be roughly equal. So let's see. Does that look good? Or does that look better? Okay, I think that, oops. That's pretty close there, but yeah, this is a pretty tough one here. Okay, let's go with that one. Now that would be, let's say that's my guess for the line of best fit. You might have something slightly different. So now what you want to do is you want to find the slope and the intercept if it's not 0. And this one appears not to be 0. So for me, this one I'm going to have to guess on what this intercept value would be. And I'm going to say about negative 0.5 for mine. Okay? And I'm going to say the slope. Now you have to calculate the slope here. So you have to pick 2 points that look to be on the line. So I'm going to use this point. And I'm also going to use... I guess it goes through this point. So I'll use those two. So I'm going to say 2, 1. And over here is 10, 6. Does everyone see that? So what you're going to do is you're going to find the slope. So for these 2 points that I picked on my line, I'm going to go 6, that's this value, minus 1, that's this value. That's on top. That's the rise. And the run is going to be 10 minus 2. And we've done this before, so hopefully this is not brand new for you. Everyone should be awake and not sleeping right now. Hi. Okay, so the slope is about 5 over 8, and the intercept here is about negative 0.5. So your equation for this line, for my line of best fit, is going to be about this, 5 over 8x. And then you could write this as a decimal or a fraction. So I'm going to go minus 1 over 2 to keep them both fractions. Okay? So that's what I would put for mine, and you can do decimals if you want. Let's see theirs. Okay, so their line looked a little bit different than mine. That's fair. They had a direct correlation because theirs went through 0. Mine almost did. Okay? So there you go. So lines of best fit, you with your ruler or straight edge, draw a line that you think goes right through all the points. Questions there? And it's okay for the lines to look just a little bit different. Okay, so let's do this one together. I'll do A with you, and then you can do B. Okay, so a line of best fit. So I'm looking at this data right here, and I'm seeing a couple things. I'm seeing that generally the points kind of go up in both directions. As this increases as well. It kind of goes up. I'm also seeing that this is an outlier. That looks to be a little bit of an outlier there, right? It's kind of a fluke, right? So let's say I'm going to draw my line somewhere around here, and it's going to look, whoa, not like that. It's going to look something like that, okay? So you're going to draw your own line, I'm going to draw my line, and my line looks something like that. So it says, draw the line of best fit and write an equation. Well, there's the line of best fit, and my equation, we all know, has to be y equals mx plus b. So I'm going to find the slope. And again, you have to pick 2 points that are on the line. And I only have 1 point here that appears to be on the line. So then you pick another value, and I'm going to use this one. This is like the point 0, 6. See that? 0 up 6. That point is on the line. And this point appears to be 9, 9. You see? It's right here, 9, and right here. So this point is 9, 9. And 0, 6. So the slope is going to be y1 minus y2, or y2 minus y1. So let's go 9 minus 6 on top. That's the rise. That's the difference in the y values. And then the run would be the difference between the x values. So that's going to be 9, minus 0. And the slope, that's going to be what? 3 over 9. Or a slope of 1/3. Or if you want to put it in decimal, you just go right ahead. 0.33. I mean, it's repeating, right? Okay. And then, so my y-intercept is 0, 6. So guess what? My b value is 6. So I'm going to put 0.333 in there, and I'm going to put positive 6 right there, and that's going to be my equation. So y equals the slope of this line I calculated to be this, 0.33. And then I'm going to have an x in there, right? Because I got to have the x here. And then b is positive 6, so I'm going to write this as a plus 6. And that is the equation for my line of best fit. And yours might be the same, it might be a little bit different. Questions on that, guys? Any questions at all? Okay, so your job, why don't you just take a moment and finish, finish like question, let's see, why don't you take 10 minutes and finish 2 and finish 3b here. What's over here? And then 4, you know what, we'll see how far you get. But finish 2, 3, and then work on 4 if you have time, okay? Because we will probably go, I might show you a little bit more here today. So take 10 minutes and work on those questions. All right, example 3. This is a different type of graph we're doing. This one's a little bit more complicated. It's not that difficult, but let me just walk you through what could be learned from a graph like this. So really, we have 3 different quantities that are represented here on the graph. So let's just read it and I'll show you. Edie surveyed students in her class to find out, Edie, to find out if the time they spent watching TV was related to the time they spent studying for exams or the time they spent exercising in 1 week. So she created the following scatter plot. So here's the thing. She asked, how many hours do you spend watching TV per week? And she asked a number of people, right? And then she also asked them, how much time do you spend studying? And how much time do you spend per week exercising? So there's 3 questions she asked a number of different people here. Okay? So it appears that there's so this might be one person here, right? This might be another person here, because a person that says they watch 5 hours a week would probably answer here in this 5 hour, right? And so there's one person, there's 2 person, there's 3 people, there's probably 4, there's probably 5, 6. Now this could be 7 and 8 and 9 and looks like maybe 10, although we have this one, I'm not sure what this is about. So it looks like they asked maybe 10 people, okay? Now you're going to do something similar to this, but let me explain how this sort of works. So what she wanted to know is there a correlation between the number of hours that you spend in a week watching TV and exercising, or watching TV and studying? And look at what she found. She wasn't sure what she was going to find at the beginning, but look at the black lines, okay? So I'm going to draw a line of best fit for the black lines, roughly. It looks something like this, okay? You don't have to put a little arrow on it. But and the black lines are actually pretty close to this line, aren't they? Okay? So there appears to be a correlation or a relationship between what hours you watch TV and time spent studying. And what is that relationship? Who can describe this relationship for me between watching TV and studying? What'd you find? Anybody? Okay, so let's go here. So look at this for the black dots. As the time spent watching TV goes up from person to person, what happens generally to the time studying per week? Do you see how the line goes down? So a person that spends 5 hours watching TV spends 13 hours studying. Generally, as people spend more time watching TV, they spend less time studying. That's what she found. That's what the data says. Okay? Does everybody see that? We aren't answering here. I thought someone would jump at that. Does everyone see that, though? Watching TV versus the black one, which is studying. So let's take a look at the gray one now. Okay? The gray one. So if you can just pick out the gray dots, it's a little bit tougher. But the gray dots seem to be all over the place, don't they? Okay? So there's maybe not as much correlation here between watching TV and time spent exercising, because it's a very loose kind of correlation there. Oops, I always keep putting an arrow there. It's a very loose correlation, and like it's almost like not correlated at all. Do you know what I mean? So it's not really positive or negative. The correlation is very weak. And so she might say something like, you know what, as people watched more and more TV, their exercising went down a little bit. Like if they watched more than 15 hours a week, their exercising definitely went down. But people that watched less than 17 hours a week, some of them exercised a lot and some of them exercised very little. There's no correlation there. So there's a lot you can learn. Okay? So what I'm going to get you guys to do, and I'm not going to go over really all the questions here, but here's their lines of best fit, and this dotted one means, hey, it's really, really weakly correlated, but the more time that her classmates spent watching TV, the less time generally they had for other things, which makes sense. So this is what I want you to do, okay? And you're going to be able to do this maybe instead of some of your build the skills questions possibly. But this is what I want you to do. So think of 3 questions that you can ask in a survey of your schoolmates. So it's not just our small class here, but I'm going to get you to ask your grade 12 class, okay? And you need to pick at least 10 people, at least 10, okay? So your schoolmates, so greater than or equal to 10 grade 12 students, okay? Got it? So I want you to come up with your own questions that you think may be related. Like this is to help you discover something that you're curious about, okay? And so I put down an example here. And again, I would like you to try and think of 3 different questions that may or may not be related. But these are my examples. How many hours do you spend on social media in a month? And that may be a tough one. You might have to go a week. You might have to just go a week for these ones. So I could change that right now to a week. And you could do a month if you thought that was better. But let's say, how many hours do you spend on social media in a week? And then how many hours do you spend on household chores in a week? And how many hours per month do you watch? How many hours do you watch? We're going to change those months, right? How many hours do you watch TV in a week? So you might find that, if a person spends more time on social media, that they also spend more time watching TV. Or you might find that if someone spends a lot of time on social media, they don't watch TV as much. I don't know. Or chores. Maybe if someone spends very few hours on chores, maybe they're watching TV and doing social media quite a bit more than someone that has a lot of chores. Do you know what I mean? So you can learn a lot just like that other question. So one of these is going to be kind of your independent variable. You're going to start with that, and you're going to say, like for example, let's say chores. That's going to be the independent one. So you're going to say, all right, I want to plot, here's chores down here, and for a week, let's say here's 5 hours, and here's 10, here's 15. I don't know. Anybody spends 15 hours a chore in a week? Maybe. Or 7, that's 2 hours a day. I don't know, maybe. But let's say you ask 10 people and you have this. So for social media, if someone spends 5 hours, they spend like this much, 10 hours on social media or something. If someone actually spends 11 or 12 hours doing chores or working on the farm or whatever, then maybe they have something like, I only spend 3 hours, wherever 3 would be. So you might find that there's a trend there, or you might find for chores and TV that maybe there isn't a relationship. Maybe you think, well, it's kind of all over the place. Chores and TV I don't know. So you're going to ask these questions. So you're going to make a tally sheet, and I can help you with that if you want, but you're going to have sort of person 1, person 2, person 3. You don't have to have their names, but you're going to say, give me the answer to this question, and this question, and then you're going to plot it. And I want you to talk about the trends that you see in your class. So take, you can take the rest of this class to think of 3 questions that you are wondering about, And again, don't make them too personal or too silly or too whatever. You know what I mean? They've got to be like half decent questions. I would like you to maybe run them by me as well, just so you know we both have the similar idea of appropriateness. And it'll also be something too that, you know, might have some kind of relationship that you can actually see. But anyways, so think of 3 questions, and I want you to ask at least 10 people those 3 questions, and it has to be a number attached with the answer, right? Like, not necessarily what's your favorite color. You have to ask something that you can quantify. I guess it could be color. You could ask your favorite color but you'd have to have some kind of numbers for the other 2 questions. Like, what's your favorite color and how far do you drive to school every morning? Or how long does it take you to get to school? I don't know. Maybe there's a correlation between that. Maybe purple people live far away. I don't know, from school. I don't know. Maybe like if you like yellow, you live really close to the school or something. I don't know. Like you never know. There might be a correlation between silly things. So at least 2 of them have to be sort of like numbers or quantitative data like that. Does that make sense? Yellow people live close to the school. Purple people live farther away. I don't know. Who knows? Okay. So there you go. That's what I want you to work on right now.